Ever wondered what really happens when you pull the pin on a grenade? It's a marvel of miniature engineering designed for maximum effect. Let's break down the science behind one of the most iconic pieces of military hardware, the fragmentation grenade. Inside this small, unassuming package, you'll find several key components. It all starts with the safety pin and the striker lever, or as many call it, the spoon. When you hold a grenade, you're pressing this lever against the body. The pin is what holds the lever in place. Once you pull that pin, the only thing stopping the process is your grip. Let go of the lever and a spring-loaded striker is released. It swings over and hits a tiny percussion cap called the primer. This impact creates a small spark, much like a cap gun. That spark is the starting pistol for a very fast race. The spark ignites a chemical delay fuse. This is a slow-burning compound packed into a narrow tube. It's carefully designed to burn for about 3 to 5 seconds. This critical window gives the thrower just enough time to get the grenade to its target and find cover before it goes off. As the fuse burns down, it's like a countdown timer ticking away. Once the delay fuse burns all the way through, it ignites the detonator. The detonator is a small but powerful charge that sets off the main explosive filler inside the grenade's body. This filler is typically a high explosive material. When the main charge detonates, it creates an enormous, instantaneous buildup of high-pressure gas. This pressure shatters the grenade's outer casing, which is usually made of scored cast iron. The casing is designed to break apart into hundreds of tiny, high-velocity metal fragments, or shrapnel. These fragments fly outwards in all directions at incredible speeds, and that's what makes the fragmentation grenade so effective. But not all grenades are designed to fragment. There's a whole family of them, each with a specific job. Take smoke grenades. These don't explode. Instead, they release a thick cloud of colored smoke, used for signaling or creating a visual screen. The internal chemical reaction produces a dense aerosol of microscopic particles, creating a persistent plume of smoke. Then you have stun grenades, also known as flashbangs. These are designed to disorient, not injure. They produce an incredibly bright flash of light and a deafeningly loud bang, temporarily overwhelming a person's senses without causing permanent harm. The charge inside is usually a magnesium-based mixture that burns extremely quickly and brightly. For sheer destructive heat, there are incendiary grenades. The most famous type uses thermite, a mixture that burns at over 4,000 degrees Fahrenheit. That's hot enough to melt through steel. These are used to destroy equipment, vehicles, or structures. The chemical reaction is so intense, it creates its own oxygen, meaning it can't be easily extinguished. Finally, we have offensive grenades, which are a bit different from fragmentation grenades. They rely on the concussive force of the explosion itself rather than shrapnel. They have a larger high explosive charge, but a much thinner casing made of cardboard or plastic. This makes them ideal for enclosed spaces where fragments would be just as dangerous to the user as to the target. To get grenades further than a person can throw, there are grenade launchers. These devices can fire specialized grenades with greater accuracy over longer distances, sometimes hundreds of meters. Understanding the mechanics of a grenade also means understanding its dangers. The blast radius and fragmentation pattern create a significant kill zone, and safety protocols are extremely strict. The science is fascinating, but it's a powerful reminder of the precise engineering that goes into military technology. So, from the simple pull of a pin to the complex chemical chain reaction, a grenade is a perfect example of controlled power packed into a small device. Each type, from smoke to stun, has its own unique scientific principle at work. Thanks for watching our deep dive into the world of grenades. If you found this interesting, be sure to like this video and subscribe for more explanations of how things work. See you next time.